Hello, Assalamualaikum. Hi everyone. My name is Madhav and today we are going to discuss about the projectile motion, which is a topic of the physics. First of all, in today's video, I will only discuss the basic of the projectile motion. I will not go into the detail of derivations of the formulas and will not discuss the formulas as well. We'll just discuss the basic things, basic concept of projectile motion, which is very important to understand first. So first need that you need to understand is that this is the what we say dimensional two dimensional what we say plane. Okay, so first of all we need to understand that what is projectile motion. Projectile motion, for example, this is a plane. Okay, if you know the coordinates, so you will easily understand this is a x, this is y, this is z. When you cover distance in this direction, it will call the one dimensional plane. If you what do you say, if you travel in both directions, for example y and x, so you will cover two dimensional. And if you cover third one as well, so it will be third dimensional plane. But in projectile motion we are only discussing y and x. For example, if you are running, if you are doing running or walking, so you will go in the x-axis. This is the example of this. And if you're talking about the y, so when you take lift, when you use lift, so it will go upward and come downwards. So this is example of y. So now you will say that what is the example of projectile motion. So projectile motion, for example, if you throw the ball from this direction, so it will go like this. All right, so you cannot decline this image that it doesn't happen in the projectile motion. It's constant that it will happen. If you throw a ball at this angle in the towards that side, so it will come down right here. All right, so now what we have to discuss is that first of all we need to understand how many forces are acting on this body. The first force that is acting on this body is gravitation. Gravitation, sorry, gravitational force. All right, means if you are throwing the ball, so it is coming down. After that, after throwing, means there's a force which is what we say, attracting this ball or any object that you have thrown towards the ground. So that's the reason it is coming down. If you don't have the gravitational force, it will directly go to the space and will go forever. But now we have gravitational force. The second thing, air friction. All right, what is air friction? Now as you know that if you throw a ball from this side, so air friction, what we say, air resistance will go against the x-axis, so it will go like there, some like there, and a results will be the not same. When we do the problems and everything regarding the projectile motion, so we neglect this air friction, means we do not consider air friction. When we do not consider air friction, means air friction is zero, air friction is acceleration, so that is also zero. When you don't have any acceleration, remember one thing, when you don't have any acceleration, the velocity will be constant. This is a journal term you need to understand. You have to remember, you have to memorize this, that when you don't have any acceleration, the velocity will be constant. All right, now we are talking about the other things as well. For example, this is the projectile motion. All right, and this is the initial point. So what do we call this? So we call this initial point as v naught. All right, only v naught. When we throw the ball, for example, if you are throwing the ball, it will go like this point is called v. Okay, and this called is also called v naught, or you can say final velocity, vf, only vf. And remember one more thing, that previously we have discussed that air friction is equal to zero, means acceleration is zero, and at zero acceleration the velocity will be constant. So for example, if you don't have any air friction, the velocity here and here will be same, here and here will be same, and here will be same. here will be the velocity will be 0. Everything will be 0 here. If you know, when you know that when you throw something on a height, on a specific height, or on projectile motion, it will go up and come down. There's a point where where it stopped and the velocity becomes 0 for a nanosecond, or you can say for some seconds, then it come down. So the same thing is happening here. If you talk about the vertical, that what are the component, like for example, there is there anything for the vertical, because we are just discussing the horizontal. So yeah, there's one thing is for the vertical, that we have the constant velocity on x direction, but we don't have the constant velocity on y direction. Firstly it decreases the values, it decreases the value, then it increases the values. For example, if you have thrown a ball with 50 meter per second with the velocity of 50 meter per second, it it goes here, it will become 10, 5, and now 0. Again it will come back obviously. So 5, 10, 15 meter per second is. So this is the thing. As you can see that velocities are changing. For example, 15, 10, 5. Firstly it was decreasing, but now it is increasing. So yeah, this is the thing that